All right, welcome. This is ACT worksheet 206, triangles. It's one of four worksheets that deal strictly with geometry before trigonometry. You have 205, which is angles, 206, triangles, 207 is circles, and I believe 208 is quadrilaterals. Triangles are important. They come up maybe two times on the test, but there are certain specific things you'll really want to know when it comes to triangles that will make your life a lot easier. Some of you may already be familiar with these, others may not. I'd really kind of break it down to four things that you really want to know. First is I would recommend, and I know this isn't common in the UK schooling system or the English schooling system, but I would really recommend knowing the proportions of the 30, 60, 90 degree triangle and the 45, 45, 90. There are ways to get it with trigonometry, which I think a lot of people watching this video do use when they want to figure out angles and proportions on a triangle. But I'm going to show you why it's faster, easier, and sometimes necessary just to know this. So I'm going to go through that in the video. Pythagorean theorem, most people already know. So I'll point it out, but I'm not too worried about that. But you're also going to want to know the two Pythagorean triplets. So I'll kind of almost write that as 3 and 4. So those are the four things that we'll really key in on as we go through this. But I'll also point out other things that are important as well. All right, so let's kind of get right into it. So you know that the interior angles of a triangle add up to 180 degrees. If you have an isosceles triangle, then that means that you have, there we go, pen. That means you have two sides that are equal, which means that you have two angles that are equal. So that's isosceles. Scalene, all three sides and angles are different from one another. Okay, so let's just get into the 45, 45, 90. So if we're looking at this triangle and we're told that this side is 10, immediately if we see, and this 45 degrees should kind of be inside here, but immediately if we see a right angle and 45 degrees, we go, oh, okay, immediately. If this is 45 and this is 45 degrees, these have to be the same. And the one across from the 90 is whatever our base side is, meaning our small side, times root 2. So this would be 10 root 2. So it's just really quick and easy. I know that some people, if they were given this, and I think probably a lot of people at this point would probably do this. If you're given that this was 45 degrees, right, and you're given that this is, let's say, 10, you'd immediately go, okay, I'm going to say sine 45 equals 10 over, and we'll just call the hypotenuse x. And then you'd say, okay, so x equals 10 over sine 45. Again, not wrong. You will get the right answer. So nothing wrong with it, but it takes a little bit longer than just knowing base, and then root 2 times the base is the hypotenuse. And I'll show you some problems later on from previous tests where you'll see why it's better to just know the proportions. And here's kind of a funny thing. You can try to race me on this one if you want to do it with trig, but I'll tell you exactly what this side is and what this side is before you even have touched your calculator. If I see that this is 90 and this is 30, well, I know the proportions to be x, x root 3, and 2x. So across from the 30 is going to be half of the hypotenuse, and across from the 60-degree angle is just going to be the base, or the smallest one, times root 3. So if you can just memorize those, I'm telling you, it will make your life a lot easier. Is it necessary? You probably get away without it if you're really used to kind of always doing it by setting up the trig. But I'm going to show you some problems where you'll see that you kind of want to just know it. Okay. And if we want to get some practice, like a really common scenario is you'll be given a square. And so if we want to know the area of this square right here, we just need to figure out one of these sides. So I'll just put like if we're looking at, if this is 4 and we have these two sides, right, we just want to know what one of them is. So whenever you cut a diagonal across a square, you form two 45-degree angles. And just knowing that the proportions of a 45, 45, 90 are x, x, and 4 is equal to x root 2, I can just go, okay, 4 equals x root 2. So essentially 4 root 2, and we're not going to rationalize it here, and I'll show you why, equals x. So if you want the area, it's just going to be 4 over root 2 times 4 over root 2, right? So that's going to get you, right, 4 root 2 times 4 root 2, or 4 root over root 2 squared. That's just going to get you 16 over 2, or 8. So the area is going to be 8 there. So it's just really kind of quick and easy if you just know the proportions. All right, let's look at this other example. So another common situation you may get is an equilateral triangle. And if we're being asked what's the area of the equilateral triangle, again, we know the base. The base is 6. It would be helpful to know the height. Some of you may already know the equation, side squared times root 3 over 4. And you just know to plug in 6. If you know that, great. But if you don't know the equation, I'll show you kind of a quick, easy way to get this one. What you'll want to do is drop an altitude. And if you drop the altitude here, what you're looking at is, you know this to be 6. Real quickly, you've created a 30, 60, 90 triangle here. Again, you could reach for your calculator for trig, but I find the easiest thing to do is to just know that the 6 is your 2x. So your x would be 3. So your height across from the 60 is going to be 3 root 3, right? Because the proportions of a 30, 60, 90 are x, x root 3, and 2x. Cool. So the minute you have 3 root 3, you just know 6 is your base, 3 root 3 is your height, and divide that by 2, right? Base times height divided by 2. So 18 root 3 divided by 2 will get you 9 root 3. So that's the way I would recommend doing that, is just knowing the proportions. Awesome. If you wanted to do it by trig, I guess what you would need to do when you create the 30, 60, 90, to figure out the height, you'd have to say, okay, sine 60 equals, and I'll put h for height, h over 6. So it would be 6 sine 60. But I'm telling you that that's going to get you the equivalent of 3 root 3. And it's just easier to know it. Okay, anyway, that's that. Let me just point out a couple other things real quickly. And obviously, feel free to read back through all the stuff I'm skipping over on your own before you start the packet. I'm just kind of hitting the highlights here. But you definitely want to know your first 2 Pythagorean triplets. In other words, your first 2 right angle triangles that have sets of integers that create the 3 sides. So the cool thing about the 3, 4, 5 triangle is that you also have similar triangles. So like if I were to just draw a bigger version of the 3, 4, 5, and I were to tell you that this is, let's say, 9, and this is 15, well, immediately before doing Pythagorean theorem, if you recognize this as a 3, 4, 5, you know this is 8. Because the scale factor was just 3, right? To get from 3 to 9 was just multiplying by 3. The other common Pythagorean triplet is a 5, 12, 13. If you think about it, 5 squared is 25, 12 squared is 144. You add those together, you get 13 squared, which is 169. So those are helpful to kind of keep handy. All right, so what we'll do now is we'll take a look at some of the problems on this packet, problems from previous ACTs that have consistently given students difficulty. So we'll look at ones that are kind of emblematic of what you need to know, and then we'll look at some of the more challenging ones. And you can pause the video at any point if you want to try to figure out the problem on your own. Okay, so let's start with 22. The other thing I'll show you on these problems is I'll also show you the logical element. The one thing, and you've seen me say this in all the videos, the one thing you don't want to abandon when you're taking this test is the idea that it's multiple choice. Although the ACT claims that you can't assume it, figures are almost always drawn to scale unless labeled otherwise. So a lot of times you can use logic as well. And I'm going to show you both avenues on this problem, logic and then also knowing your 45, 45, 90 triangle. So we have in the trapezoid KLMN below. M is 45 degrees. Angles K and N are both right angles, okay, labeled for us. And they want to know which of the following values is closest to the area of this trapezoid. Okay, so let me kind of show you a quick way. Pretend you didn't know 45, 45, 90, or pretend you just didn't feel comfortable with geometry at all. Well, if from L to M is 10, what do you think this is? I don't know, roughly. You can give me any number that you think it could be. I'd say maybe about 7. Okay, well, if we look at this rectangle right here, we think about 7 times 8. Well, 7 times 10 is 70. 7 times 18. 7 times 10 is 70. 7 times 8 is 56. So we're looking at 70 plus 56. So this would be 126. And obviously, you'd have a calculator do that as well. So immediately, if with our estimate, we're getting this part to be 126, and we haven't even added the triangle on yet, we know that none of these answers even stand a chance, and we can almost just pick E with pretty strong confidence and just move to the next problem. So again, don't abandon logic. Don't abandon the idea that it's multiple choice and figures for the most part are drawn to scale. But another way we can get this one pretty quickly as well is if this is 10, well, the proportions are x, and x root 2 across from the 90. So if you think about it, x is going to equal, if 10 equals x root 2, then x is going to equal 10 divided by root 2. So if that's the case, let's calculate what this guy actually is. So we've got 10 divided by root 2 times 18 to get the area of this rectangle. And if we do that, if we're trying to get the area of the rectangle, we end up with 180 over root 2. And I know that's not rationalized. You can multiply it by root 2 over root 2, but let's just quickly pop that in the calculator, see what we get. So that gets us, interestingly enough, 127.27. And then if we want the area of this guy right here, because it doesn't want just the rectangle, it wants the entire trapezoid, it would be 10 root 2, or 10 over root 2, times 10 over root 2, times 1/2, because it's a triangle. And what we end up with is 100 divided by 4, so 25. So we end up getting roughly 152.27. So we know it's definitely A. Awesome. So let's keep it moving. Let's go on to the next problem. They'll get harder in difficulty. That's purposeful. The way the math packets are set up are to increase in difficulty. Just like the test. As you know, the test goes in order of difficulty on the math section. 27 is a really interesting problem. What makes it difficult isn't so much the execution, it's understanding what the question is asking. So I'll give you a moment to pause the video and try it. Obviously, as always, I'll just kind of continue. So this right triangle shown below with a hypotenuse of 13 and a vertical leg of 5 is rotated 360 degrees around the vertical leg to form a right circular cone. So you're going to want to think about what that means. And it wants to know, what is the volume of the cone? Okay, well, real quickly, first things first, this is one of our Pythagorean triplets, 5, 12, 13, right? 25, right? A squared plus B squared, 144, equals C squared, 169. And 169 equals 169. So that's 12 down there. Now, what they're telling us is happening, and I'll do my best to try to draw this, is they're saying rotated about the height, about the 5-inch vertical leg. So if we rotate this around, I really drew that poorly, but like if you think about it, God, I hope this makes sense when you're looking at it. But if you think about it, like this is our cone, right? Like we're taking this 12, we're rotating the 12. The 12 is our radius. I really didn't draw this to scale, so my apologies there. I was trying not to cut into the answers. But 12 is our radius, 5 is our height, and that's our cone. And the 13 is just our slant height, but it really doesn't come into play much here. So if we want the volume of a cone is honestly the volume of a cylinder, which is pi r squared times height, and it's just a third of it. Because if you think about it, a cone is going to be less than a cylinder, the way it's shaped. So now getting the answer is fairly easy. We know that pi, our radius is 12, so 12 squared is 144. Our height is 5, and we're dividing this by 3. So if we pop that into our calculator, we'll see which answer we're looking at. So I'm getting 240 pi. Hopefully you're getting the same. So that's your answer to that one. All right. I think I've picked out 2 more problems for us to take a look at. Maybe 3. We'll see if we do all 3. Okay, 28 is the perfect example of why it really, really, really helps. This is a hard problem, but it's a perfect example of why it really helps to know 30, 60, 90, and 45, 45, 90 proportions. We'll get into that, and that will be the second way we do this problem. The first way we're going to do it is we're just going to do it by logic, and we're going to see where that gets us. Because if you're stumped on a problem and they give you measurements, you can always estimate the other measurements and see what happens. At the very least, you'll be further than being completely stuck and not knowing which of the 5 answers to choose from. You'll at least be able to eliminate a few. Okay, so let's do it that way first. So in the figure below, ACD is a right triangle. B lies on AC, and the measures of angle DAC, so this angle, is 30, and the measure of DBC is 45, and we're given that AB is 10 yards, and it wants to know what is the approximate length of CD. Okay, easiest way to do this if you're not sure is know that this is 10. So if we extrapolate, and you can even take like a piece of paper, anything you have handy, and try to measure that, but if that's 10, gosh, I'd say from here to here is probably 10 if we put that there. So based off of that, I'm going to estimate that the correct answer is D. Okay, I know it's definitely not A. I know it's definitely not B because this is 10 and this is definitely greater than 10. And then the question is this 2.5 tens? And I definitely don't think that's right either. Right, if you just by eyeballing, it's not even 2 tens. So we know it's going to be either C or D. So you really have a 50% chance just by kind of pausing, taking a deep breath, and being logical. All right, let's see if I'm actually right, if this actually is D. If my memory serves me correctly, I think it's actually C, but let's see. I had a 50% chance. So here's what you do need to know. So going back, I don't expect you to necessarily have these proportions memorized yet, so I'll quickly draw it. If this is A and this is D and this is C, right, and this is 30 degrees, we have x root 3 across from the 60, and 2x. And then also, on a 45, 45, 90, maybe I'll draw that one right here. So 45, 45, 90. We have x, so our base angles, and x root 2. Okay, so I'll show you how we can put that to work and why we kind of do need to know that for this problem. So I know this to be x, and I also know if you look at, probably shouldn't do it in black, if you look at the 30, 60, 90 triangle, I know that it's also the smallest, the side of the 30, 60, 90 triangle. So it's the smallest of the 45, 45, 90, but it's also the smallest of the 30, 60, 90. So if that's the case, we can just call it x. We can call this whole thing right here across from the 60 degrees. This is, that doesn't look like a degree sign. So let me make that a little better. There we go. A little better. We can call this x root 3. Okay, so here's what we know. And then this is also, from here to here is x, right? This is x, and this is x. So what we can do to figure out what exactly x is we can say, okay, well, 10 plus x, right? We know that because they give us the 10 and we have the x from the 45/45/90 for BC. That's equivalent to x root 3, which is the 60-degree angle of the big triangle, which is a 30/60/90. So hopefully that makes sense. So then if we want to figure out what x is, well, we know 10 equals x root 3 minus x. So that's like 1.7 something x minus x. And what we get when we do root 3 minus 1, right, or x root 3 minus x, is we're going to get 10 equals 0.732x. Divide 10 by 0.732. And we get 13.66. So I was wrong. The correct answer is C. But again, if you had no clue what to do with this problem, at least you had a 50% chance with the initial way. And hopefully you would have guessed correctly or measured better than I did. Anyway, we'll do one more problem, and then that will be it for this. You can decide between the two that I've circled. I think the better one to do is actually the initial one that I had circled. So we're going to do number 30. Feel free to pause it. Before you pause it, though, let me say one thing. You can 100% get this answer very easily by being logical, and it will take you less than 30 seconds. So before you look to do any math, just see if you can get it using logic. I'm going to continue, and I'm going to show the logic way first, and then I'll show how to do it using geometry. So let's read this. So in the figure shown below, ABD lie on a circle whose center is O. Diameter ABC, a diameter is AB, as we can see. CD is perpendicular to AB, which they've marked. And they tell us that A to D is 5. So this guy right here is 5. And the length of B to D is 12. So that's easy. It's a 5, 12, 13 triangle. So we know A to B is 13, right? Pythagorean triplets. And wants to know what is the length in meters of CD. So I will put that in yellow. Keep the eye on the prize. So we want CD. Okay. Easiest thing ever to do. And here's just the logical way to consider. So I'll call route number 1 just being logical. Okay, well, this is 5. C to D is not the hypotenuse. This is a right triangle. C to D has to be less than 5. So it's not 13. It's not 156 divided by 5, which is going to end up being over 30. It's definitely not 60. And 65 divided by 12, well, I know 5 times 12 is 60. So I know this is greater than 5. So it has to be A. Incredible. That problem is really that simple. Here's how you'd have to do it the alternative way, but we will look at this other way because it's always good to see the math behind it. So you'd have to know that when you take the two endpoints of any diameter and you draw to any other part in the circle, that creates a 90-degree angle. So you'd have to know that ADB is a 90-degree triangle. It's a right triangle. If you know that, you actually know that all 3 triangles, the middle one, I'll do the middle one in green. The middle one, the big one, ADB, and the small one, which I'll do in pink, they're all similar. How do we know that? Well, the big triangle has 90 degrees in angle B. The medium triangle also has 90 degrees in angle B. So by angle, they're similar. The big triangle has 90 degrees in angle A. The little triangle has 90 degrees in angle A. So by angle, they're similar. So these triangles are all proportional to one another. So let's kind of go from there. So it wants to know the height, the medium side. DC is kind of the medium side of the smallest triangle. So what we know is medium side to the hypotenuse, the big side of the smallest triangle, is equivalent to, on the big triangle, the medium side on the big triangle is 12, right? DB. And the hypotenuse on the big triangle is 13. We didn't need to use Pythagorean theorem. We just need 30, 60, 90. So we have 13m when we cross multiply equals 60. So m, meaning the medium side, meaning DC here, right, this one, is going to be 60 divided by 13. So that's how you get it exactly. Anyway, I hope this is helpful. I hope I've helped convince you that it's worth your time to memorize the 30, 60, 90, and 45, 45, 90 proportions. You can always go on Google and type in worksheet for 30, 60, 90 problems or special triangle problems, and maybe just do a wrap of maybe 10 to 15 of those problems. You'll have the proportions down immediately, and then you'll be able to apply them on the ACT. Anyway, good luck with this worksheet, and as always, feel free to return for any other videos.